What is going on YouTube? It's me, and I'm back here showing you another Redstone video. As you can tell, usually I do tutorial videos on basic Redstone stuff, but I wanted to show just kind of one of my builds that I've been working on for a while that I'm actually very happy that I got finished with right now. And this is a multiplication calculator, and what it does is it'll actually take any of these values, these 10 values right here, because let's say we have an invisible one where if none of these are selected, it's 0, but then this lever's 1, 2, 3, 4, 5, 6, 7, 8, 9, and it's going to multiply it by this wall, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, and of course, if none of them are flipped, it's 0. And I actually have the binary outputs. You actually kind of have to look at it like this. Because the rightmost bit right here is your first one. As you can see, I labeled them on signs to make it a bit easier to figure out what the numbers are once we get them. But because of how the redstone worked out, this guy right here is actually going to be our first bit. I just wanted to show you that this thing actually does work. So let's say we have 1 times 0. We're going to get 0 out. But let's say we do 1 times 1 now, and you should expect that leftmost bit to be on, which it is. And I'm just kind of picking arbitrary numbers at this point to kind of multiply. But basically this will work for any value that you want to give that can be multiplied. It can give us pretty much anything, but for prime numbers that are greater than 10. So let's say we want to multiply, let's do 2 times 8, give us 16. So our 16 bit should be on, which you can see the calculation just got done. And this is our 16 bit. So 2 times 8 is 16. And we're going to give it, let's give it a hard one. Let's do 6 times 8. That sounds good. We should get out 48, which as you can see is 32 plus 16, so it's 48. And that's just our binary output for it. And let's actually multiply that up by 9. 6 times 9 should be 54. As you can see, we got 32 plus 16, which is 48, plus 4, which is 52 plus 2, which is 54. So as you can see, that's 54. I'm multiplying that out. And let's go ahead and crank this up to 9 times 9, show you the maximum value. And this should be 81, which is 64, plus 16, which is 80, plus 1, which is 81. So as you can see, this thing right here does in fact calculate all these values correctly. And of course it does a lot more, but this is actually a design I invented myself. I don't know if anyone else has had the idea. It's possible that someone else has. But this is actually a design that I made myself. I'm going to show you the redstone back. So this is actually all of the calculating mechanism that goes behind multiplying and adding these numbers together and figuring out exactly what they are. And these floating bits I actually don't need anymore. But they were very important while building this thing to keep track of what bit I was on, which it's very complicated. I know that if you guys just kind of watch my channel right now and you're actually learning Redstone, you're not necessarily going to get all of this. But for some of you Redstone whizzes, you'll get this right away, and then for future people, you'll be able to understand it. Well, basically what I did was, I took all these, and I have torches on the back of them, right? And I separated out all the lines. And basically, whenever I flip the line for 1, it's going to turn on the line for 1. It's going to allow 1 to be transmitted down this line. So basically, it sends the value for 1 into here, which is 0001 is 1 in binary. And of course, it just goes to 4-bit numbers up to 9. And as you can see, if we were to do 9, it would put 9 in. And basically what this does is this is a bunch of double NOT gates. As you can see, every other inverter is a double NOT gate. So I have a bunch of rows. Basically, this signal gets transmitted through here. Then it also comes out over here. As you can see, this is 1001, 1001, 1001, 1001. So basically, this just takes the signal from down here and transmits it upwards. And then I do something called implies gates, which basically this bit comes in here, and let's say I'm multiplying 9 times 1. That'll work. This does the same thing with sending out the signal. We get 0001, and each of these actually go to a different level. So as you can see, this redstone stream actually goes over here onto the second level, and then up on the third level right here, we actually have the next level of redstone that's coming in and dropping in torches, and then some more redstone that drops in torches. And actually what's happening, I want to show you, is basically this repeater goes into a comparator, and comparators are just going to send out the signal they're given. So this is sending out a signal, but let's assume that this torch we're on, and this torch is getting powered by this line. So if we break this line, that torch is going to turn on. When comparators receive signals from the side, it actually turns them off. So see, this is no longer sending a signal. So an implies gate is basically something that just allows signals to go through it, except when another output coming into it is on. So as you can see right here, what I did was I'm running all these, and if any of these signals are off, this torch is going to turn on, not allowing these comparators to send the signal. So it gets copied and pasted, and then basically what we're doing is we're multiplying the first digit by the number, the second digit by the number, the third digit by the number, and the fourth digit by the number, because if it's allowed to turn on, it's going to be multiplying 1, because all those digits can only ever be 1s or 0s, times that number. So 9 times 1 is, as you can see, our output is 9. But our second bit is our number 2 bit. So if we were to say this were allowed to send a signal, it would multiply 9 times 2, and it would actually give out 18. And that's why I had the floating bits out here, because there's an invisible bit floating out here, which I know this is complicated, and I don't expect you to understand all of it completely, because I couldn't even explain it to someone who I was very forcibly showing how all the mechanics work too. But I just wanted to kind of show you some of the stuff that I like doing on my free time on Redstone and Minecraft, just to let you know some of the stuff that you will be able to understand as we go through my series. And I also made this just for some of the guys on my multiplayer server to kind of look at this, because I thought it was cool. But yeah, so this will calculate any number that can multiply from 0 to 9 times 0 to 9. And I didn't build the display. I'll actually show you what a display is so you understand why I didn't build one. I built one way over here. And this is actually my one that multiplies 2-bit numbers. So you can see this is 1 bit, that's 2 bits, that's 1 bit, and that's the other bit. This is my addition calculator. I actually did build a display for this. And this is something called a bus, or a decoder. And basically what this does is this decodes for every value that you can get out of this. You have to have one hard bit of data. So you see this is all zeros. This is your 0 line, and this 0 line is going to tell the display to show 0. But let's say we are adding 9 plus 0 for the sake of doing it. And that was actually going to be my subtraction function I was going to add to the calculator. I haven't done it yet. But see, this is 9, 0, and the 10th line down here, because we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is our line for number 9. And it's going to tell this display to show the value of 9. So basically I have to have a hard bit of data for every number I want to be able to be showed back here. So basically for this calculator, you can see how many pieces of data. If I wanted to have 81 outputs plus 0, I would have had to have 82 rows of that thing going back and forth. Minus all prime numbers, because you can't get a prime number with this calculator, obviously. But as you can see, I didn't want to go through and calculate all of that at one time. So I just kind of built the binary output for it, and I'll probably put the decoder on it later, off camera, because that's going to take a fair bit of time to build. But yeah, this has been my multiplication calculator, and I'm sure I'm going to have another video probably showing you just how a 2-bit calculator works, just so you can kind of understand the mathematics behind it. But it's a really cool idea. I highly recommend people who who want to learn redstone and binary and all that, really tinker with addition and subtraction and all that. And if you're feeling risque going into multiplication and kind of learning multiplication, this was one I designed myself. I'm sure there are better ones, but it's still pretty cool and it gives you all the values out. But yeah, I'd like to thank you guys for watching. Please remember to comment, rate, and subscribe, and I hope you guys all have a great day. And I'll talk to you later.